In this lesson, we talk about Irradiance Map and we'll see how it works in theory, and we'll try to create a GI solution for our simple and complex scenes. And finally, we'll see what are its strengths and weaknesses. Get ready for a very long lesson. The key difference between Irradiance Map and brute force is the fact that in Irradiance Map, instead of computing GI for all the shaded points that are visible to the camera, GI will only be computed at some points and interpolated for others. Let's open up our render settings, enable GI, and set Irradiance Map as your primary engine, and set the secondary engine to none. And as you can see, there is no Irradiance Map in the secondary engines. That's because it only can be used as the primary engine. Let's open up our frame buffer and see how Irradiance Map works. Let me hide the history panel and have my render settings window also open besides the frame buffer. The camera is roughly here in the scene. As it is a view-dependent method, the first rays are shot from the camera into the scene to determine the placement of the GI samples. Now, remember, unlike brute force, we wouldn't have one sample at each shaded point or at each pixel. The samples will be created for only some points in the scene. Pay a very close attention to these terms that I'm using, because unless you really want to understand how Irradiance Map works and how those parameters are going to help you come to a better GI solution, you really need to focus and pay attention. Okay, so when one of these rays hits a surface, a GI sample will be created. From these points, the hemispherical burst of GI rays will be traced into the scene to gather information. And the number of these rays is controlled by the subdiv, or in previous versions of V-ray, hemispherical subdivision parameter. Obviously, more rays equals to a higher quality GI solution. So when you increase this number, you're going to get a higher quality GI solution. The quality of samples are going to get increased. Okay, now that we have the GI solution for some of the points in the scene, what about the points that weren't lucky enough to get any GI samples? Now, for those points, V-ray takes some of the already calculated samples from around that point and interpolates between them and averages them out to come out to a solution for that point. And the same thing will happen for the other unsampled points in the scene. And like before, if we have a secondary GI engine enabled, when a GI ray hits a surface, the secondary engine tries to bounce that ray in the scene. One essential thing you need to know about Irradiance Map is that it's produced in several passes. What I mean by that is, let's say in the first pass, the samples are created all over the place in a random fashion. In that first pass, Irradiance Map tries to assess the scene and see where are the details in the scene. In the next passes, in each pass, it tries to add more samples to more detailed and more complex parts of the scene. We will visualize that in a few moments. Now, let me close my frame buffer and get back to the render settings. Now in the render setting and in the V-ray tab, let's turn on use local subdivs. I won't mess around with image sampler settings just to avoid any confusion here. Okay. In the global switches rollouts, make sure don't render final image is disabled. If this is enabled, only the GI will be calculated and V-ray wouldn't render the final image. Also in the render elements tab, I have global illumination and lighting passes. Also, I'm going to select my light and increase its subdivision to 64 so we wouldn't get any noticeable noise from our direct lighting. In the GI tab and Irradiance Map rollout, make sure the interface is set to Expert by clicking on this button twice. And let me set my current preset to medium and take a render and see what we get without changing anything else. I mentioned that Irradiance Map is created in several passes. Now, based on our settings, we are using 3 passes to generate the Irradiance Map. We can decrease or increase the number of these passes very simply. In the first pass, it tries to get an idea of the scene, and in the following passes, it adds more and more samples to the detailed areas. And after these passes are calculated, we start to render our final image. This is our first render, and as you can see, it took about a minute, which is very quick, and we have a fairly clean GI solution. And if I go to the GI pass, you can see it's clean, even though it might lack some details compared to a brute force. These noises are actually coming from the light, but to increase the speed of these renders, I didn't increase the light subdivisions that much, so these noises are coming from our direct lighting. Now let's close our frame buffer and start explaining Irradiance Map parameters. The first parameter is current preset dropdown. We have custom, very low, low, medium, medium animation, high, high animation, and very high. So obviously when you go from very low to very high preset, you are going to increase the overall quality of your Irradiance Map and also increase your render time. Each of these presets contain predefined settings for some of the Irradiance Map parameters, which are min and max rate, and color, noise, and distance thresholds down here. Right now we don't have any idea what these parameters are doing, so let's set this preset to custom so we can adjust these parameters as we wish. The first and most important Irradiance Map parameters are min rate and max rate. Remember, we mentioned Irradiance Map is created in several passes, and each pass adds more samples to the more detailed areas. Not only we can control the number of these passes using min rate and max rate, but we can also control the resolution at which those GI passes are being calculated. Right now, min rate is set to -3 and max rate is set to -1. That means we have 3 passes, -3, -2, and -1. If I change my min rate to -4, now we are going to have 4 passes, -4, -3, -2, and -1. And if, let's say, max rate is set to 1, now we will be having 6 passes, -4, 3, 2, 1, 0, and +1. And with each pass, we'll add more samples to the detailed areas. Now let's set the min rate to -3 and max rate to 0. Min rate determines the resolution of the first GI pass, the one with the least amount of detail. If min rate set to 0, this pass would have the same resolution of the final image that you are having. If set to -1, it would have half of the final image and half of the final image resolution, and so on. So when set to something like -3, we are using a very low resolution to calculate the first GI pass, and this pass would be good enough for large, flat, even areas. And as we go through the other passes, we increase the resolution twice each time and add more samples to the detailed areas. And max rate determines the resolution of the final GI pass. Now let's see that in action. Make sure show calculation phase is enabled so we can see these passes. And also let's change the preview from full preview to show new samples in green. Now in this preview mode, each pass adds new samples in the detailed areas, and we only see those new samples in each pass. Now, when we will render, you notice that in the first pass, the samples are very random, and with each new pass, we focus more on detailed areas. In this case, let's set the max rate to 0 and open up our frame buffer, and let me clear the current render and start a render. Now, the first pass is very quick, and we randomly generate some samples in the camera view. In the second pass, which is twice the resolution of our previous pass, we only add more samples to the corners and smaller details. And in the third pass, we even pay more attention to those more detailed areas. And in the final pass, we barely add any samples to any flat areas and pay even more attention to the corners and complex intersections. On the red wall, those green samples are shown as black, but it's just a preview and doesn't matter that much. So clearly, if you use a min rate of, let's say, 0 and max rate of 3, you're going to also have 4 passes. But those 4 passes are going to be having higher quality compared to, let's say, -3 and 0. So they would take more time to calculate, and at 1, when we're using the pass 1, for example, we are going to have double the resolution of the final image. But the right thing to do is to always set the min rate as a negative value, so we can calculate less interesting and more flat, even areas very quickly. So the higher resolution passes would be used to calculate more complex areas. In the V-Ray tab and global switches rollouts, let's make sure don't render final image is inactive. Now I have 2 renders to show you, one with the min and max rate set to -7 and -4, and the other one with min and max rate set to -3 and 0. In the lower quality renders, you can see tons of details are gone. Take a look at these legs down here, and if you compare it to our higher quality render, you can see the contact shadows are almost gone, and you can see that throughout the scene if you pay close attention. And you can also see some artifacts here and there. Now let's get back to our render settings. Next we have subdivs, which controls the number of primary GI rays. So the higher this number, the higher the quality of our GI samples. Let's render our scene with different subdivs number and see what we get. In the first render, subdivs was set to 1, and as you can see, we have an extremely splotchy render. That's because each sample can send only one ray, and the quality of those samples are going to be very low, and they are going to be very inaccurate. Now in the second render, the subdivs was set to 4. So each sample can have up to 16 rays, and obviously the quality is a lot better compared to our previous render. In the next render, the subdiv was set to 10, and obviously the quality is a lot better. And you can also check out the GI passes and the RGB passes to see how they differ. Next we have 50. So we basically have a clean render. Now each sample can send out up to 2,500 rays into the scene. The averaging of all of those information is going to result in a much more accurate result compared to our previous renders. Now for such a simple scene, 50 would possibly be more than enough, but in more complex scenes we can increase these numbers, and in this case I have this render with the subdiv set to 200 here. As we increase the subdivs number, you notice the render time is also increasing. So basically, calculating the irradiance map passes are going to take longer because the sample's sending a lot more rays as we increase the subdivs number, but also the quality is getting better. Next, we have interpolation samples, which is the number of samples to interpolate the global illumination at a given point. You remember when I said that in Irradiance Map, GI will be calculated only for some points. For those points without any GI samples, the GI will be calculated by interpolating and averaging the neighboring samples. Now, the number of those samples is controlled by interpolation samples number, or interpolated samples number. To see how it works a bit better, let's decrease the subdiv number to 4 and render a few images with different interpolation samples. In the first render, the interpolation sample is set to 1, and as you can see, it's very blotchy. In the next render, it was set to 4, and we get blurrier results compared to the previous one because now we are using more samples to interpolate a given point. As I increase this value to 10, 20, and 80, you can see each time we get less splotchiness, more blurriness, and less detail in the scene. Next, I increased the subdivs to 50 and repeated the same process. Now, the individual samples are having a higher quality solution and they are more accurate. As we use lower interpolation values, the result is splotchy with more detail, and as we increase it, the result gets blurrier and less detailed. For example, if I compare the renders with interpolation set to 20 and 80, you can see in the 80 version we lose tons of details and contact shadows compared to the when the interpolation samples was 20. So as you can see, neither the low values nor the high values represent quality. You need to stay in between, and maybe something like 20 to 35 is an accepted range to be used as your interpolation sample. But really generally depends on the scene, and as you can see, we can use very high number like 200 to solve some complex scenes. Now we're going to be discussing that later on in this lesson. Now let's set the interpolation samples to 20 and continue with the rest of our parameters. The next option is use camera pass. If you have an animated camera in your scene and you want to calculate the irradiance map for the entire camera pass in one go, you can turn this option on. So whether a fly-through animation or an animation with moving objects can benefit from turning this option on, and it helps to reduce flickering in your animation. We will be discussing how to deal with rendering animations later on in this course, but for now I think this simple explanation will be enough. Next, we have interpolated or interpolation frames. As you can see, this option is grayed out and only works when the irradiance mode is set to animation. And as the name of this mode suggests, it can be used to render animations. We will discuss it later on. Now, the interpolation frames number controls the number of adjacent frames to the current frame that their irradiance map will be interpolated to smooth out the final result and remove any possible flickering. So right now the interp frames is set to 2. So if we are, for example, rendering frame 10 in the animation, the irradiance map for frame 10 and 2 frames before that frame that are 8 and 9 and 2 frames after it, which are 11 and 12, will be interpolated. So in general, 5 frames will be interpolated when the value is set to 2. Also, the number of interpolation samples depends on this parameter. Right now, 5 frames will be interpolated, so the interpolation samples will be multiplied by this number. So the overall interpolation samples would be 100 to further smooth out the final result. If you want, you can reduce the interpolation samples in that situation. Now we'll be talking about these parameters later on, and I know it's confusing right now for you, But in the final part of this lesson, when we are actually talking about the irradiance map modes, you will see kind of how these parameters relate to the animation modes in the modes down below. Now, let me for now set the irradiance modes back to single frame. Next, we have show calculation phase, and as you know, if enabled, it will show you the irradiance map passes, and in this drop down you can decide how the samples are going to show in the irradiance map calculation. Let me set these to full preview for now. Next, we have show samples, and if enabled, the irradiance map samples are actually going to show up in the final render. Let me show you a render with this option enabled. Now you can see all the GI samples that was added to the scene in different irradiance map passes. Then there is show direct light. It will show direct lighting for primary bounces in addition to indirect lighting while the irradiance map is being calculated. Generally, you really don't need to touch this option at all. Next, we have color threshold, normal threshold, and distance threshold. Color threshold controls the sensitivity of irradiance map to indirect lighting. Distance threshold controls the sensitivity of irradiance map to distance between surfaces, and normal threshold controls the sensitivity of irradiance map to surface normals. For color and normal thresholds, the smaller the value, the more sensitive irradiance map will be, and therefore the final GI solution will be more accurate and detailed. But for distance threshold, higher values means more samples where the surfaces are close to each other. That's why as I change the preset from very low to very high, you notice the values for color and normal thresholds are getting smaller and distance threshold is getting bigger each time. Now let's change the preset to medium and then to custom and set the max rate to 0. We still have show samples turned on, which is going to be very helpful in visualizing how these threshold parameters are working. In the first render, the color, normal, and distance thresholds were set to 5, 5, and 0 respectively. And if you take a look at the render, you can see even though the max rate is set to 0 and we expect to have tons of samples in complex intersections, but as you can see, the algorithm does not pay any special attention to those areas and the samples are evenly distributed because the algorithm is not that sensitive based on the parameters that we have set in our color, normal, and distance threshold. In the next render, the thresholds are set to 1, 1, and 0, and we don't see much of an improvement compared to our previous renders because these numbers are still pretty huge. In the next one, thresholds were set to 0.5, 0.5, and 0.1. Now, as you can see, we get a lot more samples in those corners and intersections and detailed areas. And in the next render, the thresholds were set to 0.2, 0.1, and 0.3. And as you can see now, because V-Ray is a lot more sensitive, we get a lot more samples in those complex areas. Now let's make sure our color threshold is set to 0.4, normal is set to 0.2, and distance is set to 0.1. Now next we have detail enhancement group of parameters, and it's very useful. If you enable detail enhancement, you can use Irradiance Map to handle the GI solution for flatter and simpler areas, and you can use brute force method to calculate GI in more detailed areas of the scene. When you use detail enhancement, you can utilize lower Irradiance Map settings because Irradiance Map will only be used for even and simple parts of the scene. In this case, let's change our preset to very low and we can increase our interpolation samples to something like 50, as all the detailed areas of the scene will be calculated using brute force. Also, let's make sure show samples is off. Now let me show you two renders with and without detail enhancement. In the first render, detail enhancement is off, and as you can see, we don't get to keep any details in the scene, especially with the high interpolation samples number that we have, we smooth out every detail. Now the contact shadows are almost gone, and you can go throughout the scene and see this lack of details everywhere. In the next render, detail enhancement is enabled. And even though the render took almost twice as our previous render, we get all the details and contact shadows back. Now let me zoom in some areas and compare this render with our previous one. Also, if I select the GI pass, these differences are becoming very obvious. As you can see in our detail enhancement version, all the details are back, but now the noise problem that we had with brute force is back again. So let's see what we can do with it. To control the quality of the detail enhanced areas, we have subdivision multiplier, and it is a percentage of the Irradiance Map subdivision. So right now our Irradiance Map subdiv is 50, and if I set the subdiv multiplier to 1, we're going to get all of those rays for the brute force calculations. And if set to, let's say, 0.5, we only use 50% of our Irradiance Map subdivision. Let's set it to 1 and maybe 5 and take a look at the resulting render. When set to 1, especially if we are in the global illumination pass, you can see not much of an improvement, but when set to 5, it's a lot cleaner, and we can clean the rest using our image sampler, but obviously the render time has increased. Next we have radius, which controls the radius for the enhancement effect. Then we have scale, which is the unit for the radius parameter. Scale is in pixel and world is in the world units. Turn off detail enhancement for now. And let me set the interpolation samples back to 20 and set the preset to custom and set the min rate to -3 and max rate to 0, and make sure the thresholds are set to 0.4, 0.2 and 0.1. Next we have randomized sample, which is on by default, and it jitters the samples randomly to prevent artifacts in the GI solution. First, let me enable show samples, and I can show you two renders with and without this option checked. When is off, you can see the samples are distributed in a grid on the scene, and when is on, the distribution is random, and normally this option should be on. Let's also disable show samples for now. Next we have multipass, and this is what gives us the ability to calculate Irradiance Map in several passes. If disabled, the map will be calculated in one pass, and the resolution of which is specified by the max rate, and it's also a good idea to have this option on all the time. Then there is sample visibility, and it can be really helpful to prevent artifacts like light leak through thin objects. When the two sides of that surface are having a very different illumination. Now let's visualize that quickly. Let me create a small plane object. Rotate it 90 degrees and put it in front of the scene besides this shelf maybe. Now let's create a V-Ray plane light and put it behind our plane. And let me also rotate it towards the bottom of the plane. Make sure its dimensions is about 10 centimeters and set its multiplier to something like 400, and maybe a bluish color here would work. Also, to see the problem a bit better, let's change the preset to low and set the interpolation samples to 100. Now, let me show you two renders with and without check sample visibility on. Now, the placement of the light and the plane might be a bit different compared to this render, but it would be enough to prove the point. In the first render, check sample visibility as off, and as you can see, the light on the other side of the plane clearly leaks and affects where it's not supposed to. And the reason being is that the interpolation point in that leaky area is using bright samples from the other side of the plane. But in the next render, when check sample visibility is on, that point is only using samples that are visible to it, so the artifact is gone and we are having an accurate render. Also, as having this option on adds another layer of calculation and complexity, the render time has increased considerably compared to our previous render. In most cases, if you are having fairly decent Irradiance Map settings, you wouldn't need check sample visibility to be on, and Irradiance Map would have done a nice job of preventing those light leaks. So for the next render, let's set the current preset to medium, then set it back to custom and change the max rate to 0. Let me set the interpolation samples back to 20 and make sure check sample visibility is off. If we render the scene, as you can see, we do not have any light leaks because the quality of our Irradiance Map is decent enough, so we wouldn't need check sample visibility to be turned on. Okay, now let me delete this plane and the light, as we don't need them anymore. Next we have calc samples. This value shows the number of already calculated samples to guide the sampling process. Values between 10 to 25 usually works. Lower values speed up the rendering, but the final solution might not be quite accurate, and higher values make the sampling more accurate, but the render will be slower. And that was me quoting the V-Ray guide. Next we have interpolation type, and obviously from the name it appears that it relates to the interpolation samples value. Here you can choose the method for interpolating samples. The default is least square feet. First you have weighted average, which is simple and fast but normally causes blotchiness in the final solution. Least square feet, which is the default method. It's better than the previous one, but it's slower. The next one is the lone triangulation, and I hope it is the right pronunciation. And unlike the other ones that try to smooth the overall result, this tries to preserve the details, and the final results might look noisier compared to the other ones. And you would need to increase your Irradiance Map subdivs to get a noise-free render when using the lone triangulation as your interpolation method. Finally, we have least square with Varani weight, which is a modification of the least square fit method, and it tries to improve upon it, but up to now it hasn't been so successful, and you're better off using the least square feet method. Now, the two preferred methods here are least square feet and the lone triangulation. Least square feet is great for simpler scenes and the result will be smoother, and the triangulation method is suited for more complex and detailed scenes because it preserves the details and wouldn't smooth out the final results. But to get a noise-free render with this method, you would need high Irradiance Map settings. Let me change the preset to very low. Decrease the subdivisions to 10. Now let me show you two renders with the interpolation method set to least square feet and the lone triangulation. Obviously, as I compared the two, you can see least square feet is smoothing out the results, and triangulation is preserving the details, and everything is sharp, but not quite in a good way. Okay, let's change the preset to medium and set the subdivs back to 50. Next we have sample lookup, and if I quote the V-Ray guide, it is the method of choosing suitable points from the Irradiance Map to be used as basis for the interpolation. and you really don't need to know how this works. And as you can see, there is a useful description for each of these methods, from draft to fast, good, and best. And the default one, which is density based, is your best bet to get high quality renders. Next, we have Irradiance Map modes. The first one is single frame, and in this mode, one Irradiance Map is calculated for the whole image and for each frame. The next one is the bucket mode, and in this mode, if I render the image, a separate interpolation map will be used for each of these buckets. Okay, we can stop the render. Another one that we have is from file. You provide an Irradiance Map file, and V-Ray won't calculate Irradiance Map again and uses that supplied map instead. Let me show you how it works quickly. So let me change the mode to the single frame. Click on this reset button to clear any existing Irradiance Map in the memory and say yes. Also, as we only need to save the Irradiance Map file, we can go to the V-Ray tab, and from the global switches rollout, enable don't render final image. Now you can render the scene. Now V-Ray is calculating Irradiance Map, and as soon as it's finished calculating, it just won't render the final image. Now we have this Irradiance Map file in the memory, and what we can do is save it on our disk, and let me save it in the render output folder of this lesson, and let's name it IR map or whatever you want. Now we can change the mode to from file and load the Irradiance Map that we just saved. In the V-Ray tab, make sure to disable don't render final image. And now if you render the scene, you notice that V-Ray skips calculating Irradiance Map and uses that supplied file and renders the final image immediately. Now the next one is multi-frame incremental. Before explaining this, let me quickly create a quick fly-through animation on my first camera. So let me close my frame buffer and render settings window. Make sure you are viewing the scene through the first camera. Select that camera in the Scene Explorer. Now let me enable auto key. Go to the final frame and move the camera as you wish. Now we can disable auto key. Now if I move through the timeline, we'll have this simple fly-through animation. I have 50 frames, and as you can see, the motion isn't very complex. So for example, if I compare frame 1 and 5, you can see the camera barely moves. So we don't need to calculate a new Irradiance Map for each frame. Using multi-frame incremental mode, V-Ray will calculate a complete Irradiance Map in the first frame, and from the next frame, V-Ray uses that first Irradiance Map as a base and adds to the map where there isn't enough detail. In our example, we can go ahead and render all the frames using multi-frame incremental, and only the first frame will get the complete Irradiance Map calculated, and the other frames will use that map as a base and refine that map where needs be. Now, in this case, because the motion isn't extreme, we can go and render, for example, every 5th frame, and in general, we will render 10 frames, right? Because we have 50 frames in general. Now, and the resulting Irradiance Map will have enough information that makes it possible to render any frame in the animation without having to calculate Irradiance Map for that particular frame separately. Let's practice what we just learned. Open up the render settings and make sure the mode is set to multi-frame incremental. Let me reset the existing map here. In the Common tab, enable Active Time Segment and set the every nth frame to 5. Now we are rendering only every 5th frame. In the V-Ray tab, enable Don't Render Final Image. Now if I press render, you can see for the first frame the irradiance map is calculated in full, and for other frames we'll use the map from this frame as our base. And because the other frames are only refining the existing map, they calculated the irradiance map a lot quicker compared to our first frame. I think it took about a minute to calculate the irradiance map for all of those frames. Now I can go ahead to my render settings and save the map that we just created. We just created one map, not 10 map, so we just have one irradiance map, but the resulting map is a combination of the irradiance map in all of those frames, each frame refining the previous frame and add a bit more detail where it needs to be. Now I can go ahead to my render settings and save the map that we just created. Let's name it maybe IR map multi-frame incremental and save it out. Now we can change the mode to from file and load the map that we just saved, and as you can see the file is a lot bigger compared to the previous file. Now I can go ahead to any frame in the scene, let's say 25 for example, disable Don't Render Final Image, and in the Common tab change the time output to single and render the image. And as you can see we have a correct final image. Next we have Add to Current Map. It's like multi-frame incremental, but in this mode an entirely new map will be created at each frame and add those new data, that new map, to the resulting map of the previous frame. So if I activate my third camera and select it in the Explorer, you can see we have 4 camera views in our first 4 frames. Now imagine I want to have a detailed high-res render from each of these views. So I can change the mode to Add to Current Map, and in the Common tab render only the first 4 frames, right? Like the previous example, I can enable Don't Render Final Image and render the scene. Now the first frame is like before, a full irradiance map will be created. In the second frame, a new map based on that new view will be created, and the map will be added to the map from the previous frame, right? We're just not refining the map like multi-frame incremental, we are creating an entirely new map for each frame and add the map that was created in that frame to the map that was created in the previous frame. So we combine those two maps in the first two frames. And after 4 frames are finished, we'll have an irradiance map that is going to be perfect if we use it to render any of those 4 frames or all of them. So you just need to save the map after the render is finished, change the mode to from file, disable don't render final image, and start rendering any of the views that you want. So the next one is incremental add to current map. In this mode, V-Ray uses whatever irradiance map left in the memory and refine that from the first frame instead of calculating a completely new map from the first frame. Now the last two ones are animation pre-pass and animation rendering. Now when you have object animation in your scene, you need to use this mode. So if you are trying to render animation with object animation, you first need to change the mode to animation pre-pass. In this mode, one separate irradiance map will be saved for each frame. So V-Ray asks you where to ask those irradiance map for this animation. In this case, we have 50 frames, so 50 separate irradiance map will be saved and later reused. So you save it wherever you want and start rendering the entire timeline. And in this case, V-Ray is smart enough to only calculate the irradiance maps and won't render the final image. After all of those frames are calculated and the irradiance map being saved, you can change the mode to animation rendering, and using this browse button, define the files that you just saved and start rendering the final animation. And for each frame, V-Ray automatically will use its corresponding irradiance map without having to calculate it again. And if you remember when discussing interp frames up here, we said that V-Ray will combine irradiance maps from adjacent frames when rendering a specific frame. So if we render frames 23, for example, V-Ray takes the irradiance map for that frame and also takes irradiance maps from 2 frames before and after that frame. 2 frame because the interp frame is set to 2, and start blending and averaging those frames together, so 5 in general, to create a smooth flicker-free solution. We'll be discussing animation rendering in V-Ray later on, but I think it's enough for now. Let's get back to the single frame mode. Next we have don't delete option, and if you have it checked, after you finish your render, the irradiance map from that render will stock in the memory, and if you disable it, it will be removed after the render. Then there is autosave. If enabled, you can specify a location, and each time a render is finished, that map will be automatically saved on your disk in the specified location. And finally, there is switch to saved map, and if enabled, V-Ray will automatically change mode to from file and uses the map that was just saved using the autosave. Okay, so that's about irradiance map. Finally, let's just get back to our complex scene and let's see how we can utilize irradiance map method in that complex situation. Now, this is the same scene that we had when we were working with brute force. And also the scene has neutral gray material applied to all the surfaces, which makes coming up with a solution a lot harder compared to a normal textured scene. The noise and splotchiness from the GI will be much more obvious in this scene. Let's open up our render settings and see what we have. As you can see in the V-Ray tab, almost everything is set to default. I've only disabled divide shading rate subdivs. In the GI tab, let's set the primary engine to irradiance map and secondary engine to none. In the irradiance map settings, let's set the preset to medium and see what we get. If you remember, the medium preset was giving us a pretty clean solution in our simple scene. But here we are dealing with extremely difficult situation where the direct lighting has a hard time entering the room and we have so many small details in the scene. Let's open up our frame buffer and let's see the render that we are gonna get. In your frame buffer, make sure display colors in sRGB space is enabled as you check out the renders. As you can see, the final render is extremely splotchy and we haven't kept so much detail. Also, if I go to the global illumination pass, we can see the real depth of our problem. Wow, it's really scary. Now let's think about the solution here. First, I'm going to draw a small region in my render so we can work a bit faster. And this is a normal workflow for me. Instead of rendering the entire image all the time, I work on small regions, and when I'm sure everything is okay, then I render the final image. Let me just arrange these windows so we have both our render settings and our frame buffer. First, let's throw in more samples by changing the preset from medium to high and render the scene. As you can see, it hasn't quite improved anything really. Now let's change the preset back to medium and increase the quality of our samples by increasing the subdivs to 100 and render the scene. As you can see, the quality has improved, especially in the flatter areas, but we still get those splotches and artifacts in the details. Now what I can do is to increase the interpolation samples to 35 in order to smooth out those splotches a bit. Now let's render again and see what you're going to get. It's better, but we still have those splotches even though less visible, and we lost tons of details and contact shadows. For most scenes, these settings would give a beautiful render. Maybe interpolation samples is a bit too much, but in this extremely difficult scene, just increasing the Irradiance Map settings wouldn't be enough to get a final result. In this case, I decided to utilize detail enhancement. So as we learned when using detail enhancement, we can use very low Irradiance Map settings because it's only going to be used for simpler parts of the scene. So let's change the current preset to low, increase the interpolation samples to 200 or even 100, 150, 200 would work in this case. Enable detail enhancement, and in this case let's set the radius to 40 pixels. Also let's set subdiv multiplier to 1 and let's render the scene. Now, as you can see, those splotches are gone. We have a faster render, but now we have lots of high frequency noise. To get rid of these, let's increase the subdiv multiplier to 3 and render again. Now, it's a lot better, and in the RG pass, it's very hard to notice any noise. If I render the entire image with these settings, you can see the final render is pretty clean. I can check out the GI pass, and as you can see, we have barely any noticeable noise, but it took more than 1 hour to render this, which is a lot faster compared to, for example, brute force, and it's a lot cleaner compared to it. Now obviously we are gonna need a secondary engine to have a profound GI solution, so let's use light cache as our secondary engine and set the subdivs to 1500s. Also in the render elements, let's add a V-Ray denoiser, and you can set the preset to mild, or it's really up to you, but in this case I just let it to be default. Now this is the RGB pass, and as you can see, it's very clean. Also, even though I've increased the resolution of this render compared to our previous render, and I've also added the light cache as our secondary engine, as you can see, the render time has decreased compared to our previous render because the scene is brighter, the more light is in the scene, and that's why we are getting actually a faster render compared to our previous render. And this is our GI pass, and if you compare it to our first render, you can see it's a lot better. And this is our denoiser pass, and it's getting rid of any remaining high frequency noise in the render. Now there you have it. Finally, we can enable color correction and maybe enable white balance and use something like 7500 to add a bit warmth to the render. Let's also enable the curves and add a bit more contrast. Also, another helpful tip here when you load these history renders in your frame buffer, which I have provided with the project files of this course, you can right click on any of them, and if you select load render settings, the settings that was used to achieve that particular render will be loaded in your V-Ray settings. Now let's quickly sum up the strengths and weaknesses of Irradiance Map. For its strengths, first of all, it's faster compared to brute force. Then you have the ability to mix between Irradiance Map and brute force by having detail enhancement option, which is a big plus for me. Another big one for me is the ability to save and reuse and refine Irradiance maps. And for its weaknesses, first, we can lose some detail when using Irradiance Map. If used for animation, there might be artifacts and flickering. Also, it needs more RAM and resources compared to brute force. So that's about Irradiance Map. A very, very long lesson, but I will see you in the next lesson. Hopefully you learned something.